Hello and welcome to another video. In this video we're going to be working on maximize happiness of selected children. And in this one you're given an array happiness of length n and a positive integer k. And there's n children in a queue where the ith child has a happiness I. You want to select k children from these n in k turns. In each turn you can select a child, and when you pick one the happiness of all of them decreases by 1 that hasn't been selected. It can't be negative and it's only decremented if it's positive. Return the minimum sum of the happiness value of the selected children you can achieve. So in this first example, essentially what happens is every time you pick a child, the happiness of the rest goes down, but you basically just always want to pick the one with the highest number first. So we'll pick this one, and then the happiness of these goes down. So this becomes a 1, this becomes a 0. Then you're going to want to pick this one. So you get 3 and 1, so you get 4. And then the second one, once you pick one child, doesn't matter which one, all of them go to 0, so then whatever else you pick, you just get 0 for the next one, so you get 1 total. And the last one, k is 1, so this is just going to be, you just pick the biggest. So you always pick the biggest, and then whenever you pick the biggest, the rest go down. So what you could do is you could like sort your array, and then you could just always say like, okay, let me just always pick the biggest. So let's say I'll pick this number, and then I'll make all these go down by 1, right? All these go down by 1. Then I'll pick this one, it'll be 8 now, and then they all go down by 1, and so on and so on and so on. But you don't really need to actually make them go down by 1. It's pretty easy to recognize that, because if I picked some number of children, let's call that x, what will the score be of the next biggest child? It's just going to be that score minus x, right? Because every time I pick a child, the scores of all the rest go down. So like when I pick this is going to be 10, and that's one child. Then when I pick this is going to be 8 because I've already picked one child. Then when I pick this is going to be 6 because I picked another child, and so on and so on and so on. So basically, the score is just the score of the child is just the score minus children picked. So all we have to do is just keep track of the children we picked and just pick the top k numbers, and we can simplify this. So let's say k, is like n in this case. Let's say k is 10. So after a while, all your scores are just going to be 0. And it's very easy to see in like this example, right? You pick one child and all of them drop to 0. And because your array is going to be in sorted order, whenever you get one score of 0, like let's say like here, we've already picked 5 children before this one, so this score is going to be 0. If this is 0, that means all of these will be 0. So we can just break the loop. So it's a pretty easy one. All you do is just you sort, and then you always just pick the biggest guy, and then you just keep track of like, you just pick the biggest k numbers, and then whenever you score 0 for one of them, you know everything before that's going to be 0, so you can just return. So pretty easy. Yeah, so let's code that. So first we can sort our, and let's actually just rename this just to make it easier. So let's call this h. And then we can say h equals, or we can say int h equals h length. Okay. And then we can have a result variable, and we can sort our array. And now we basically just want to loop from the end of our array to that end minus k. So like if k is 5, we want to look at the last 5 elements. So this is just going to be int I equals, so this is going to be h minus 1. And then we want to loop to, so let's see, so if k is 1, let's say, we want to make sure our number is above this number. So I think it's just going to be like this. It's going to be I is greater than h minus 1 minus k. That way when, and then I minus here. That way when, let's see, no. That way when like if k is 1 and we start at h minus 1, so we would start at so the length is 10, we'd start at 9, and then when we go to 8, h minus 1 minus k would be 8, so I has to be greater than 8. If k was 2, then we'd want these 2, so I has to be greater than 7, and so on. So h minus 1 minus 2 would be 10 minus 1 minus 2, which would be 7. So kind of weird going backward. You could also like reverse the array if you want to, if that makes it easier. So now we want to get our current value. So we can say int, or current happiness or something. So we can say current happiness. And this is going to be h at I minus some value, right? And so obviously it can't be negative, but we're just going to check if it's greater than or equal to 0, or if it's greater than 0. If it's not greater than 0, we'll just stop. So this is going to be hi minus how many children we picked. And the number of children we picked, we can just calculate it based on the index, or we can have a variable. So you can either just have a variable that you can increment, or you can actually calculate it based on the index. So basically, the number of children you've picked is going to be like, let's see. It's going to be like h. So when you're on this last index, you pick no children, which is h minus 1. Then for every index you pick, you go down 1 and 1 and 1 and 1 and 1 and so on. So I think this is going to be something like basically we want to have 0 here. So I think to have 0 here, you just do this, and then as this goes down, it'll get increased. So basically, if we do, once again, I'm like maybe overcomplicating, you can just keep a variable if you want to. But basically, this kind of does it. So in the beginning, I is 9, and this is 0. Then when I is 8, it'll be 10 minus 1 minus 8, then 10 minus 1 minus 7, and so on. So this will keep going down 1, so then the number of children we picked will keep going up by 1. Yeah, and then we can just say it like, or not, if current happiness is less than or equal to 0, we can just break. Or we can just return a result, in fact. We don't need to break. Otherwise, we just add our current happiness. Like I said, if this is a little bit confusing, you can just have another variable that you just increment here. You can also traverse your array forward, so maybe a little overdone, but whatever. And then you can just return a result. And yeah, I think that should do it. So whenever this happens in Java, almost always, so your number is negative and you want a big positive number, so it's almost always overflow. So yeah, they want a long, so you just turn this into a long, and then you should do it. Okay, yeah. So once again, yeah, if it's confusing for you to go backwards, you can just go forwards and kind of do the same thing. Then the number of children picked is a lot easier to calculate, right? Because like it's basically just I. So if it was sorted in reverse order, then like if you're on index 3, you pick 3 children and so on. So you would just loop from I equals 0 to I is less than k, and the number of children picked is just I. So backwards like this. A little bit hard to calculate, but regardless, yeah. So time here is O of m log n, and space is O1 because we just sorted our array and we calculate everything in place. So yeah, kind of an easy one. Just the main thing to recognize, you always want to just pick the biggest guy. And you don't need to decrement everything. I think that's also very easy to figure out. Like, whenever I pick one, I don't need to actually decrement them. I can just keep track of, like, how many that I pick. And then I know what my value is in O1 instead of having to, like, decrement them. And then you would have, like, an unsquared solution. Yeah, so that's going to be everything for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.